Great. Can everyone hear me OK? I think we're going to kick off. So welcome, everybody. Afternoon. It's great that Gdansk and Infoshare have such a great web performance scene by the looks of things. We've got 4 talks. I think I'm possibly the last one. We've had Vitaly yesterday, who talked a little bit about performance. We had Harry Roberts, Alex in the morning on this stage, and now me. So hopefully you're not kind of bored about web performance yet. So I'm going to be talking about building websites that can be fast without requiring permission. So before we kick off, who am I? I'm Ryan Townsend. I'm the CTO of a company called Shift Commerce. We're based in north of England. And we build an e-commerce platform. It's designed for kind of mid to enterprise scale retailers. So we have a strong focus on performance. This is one of our clients, a company called Matalan. And they have about $1 billion, just over $1 billion in revenue each year. And they have about 220 physical stores. So it's quite a big site. So performance is pretty important to us, both on a personal level and on a business level. I'm not going to cover too much about why it's important, why we should care about it, but I'll just cover kind of why I think it is. So when it comes to e-commerce, we have this algorithm for figuring out this is how much revenue you're going to make. You have a certain pool of traffic coming into your site. A portion of that is going to convert into an actual order, and then the orders are going to come out with an average value. So AOV stands for average order value. You multiply these 3 things together, and ultimately you get your revenue out the back of it. So performance can improve all of these areas. So if we start with traffic, when Pinterest rebuilt their site with a performance focus, not really changing the user experience or anything like that, they saw that organic traffic from Google rose by 15%. Like, Pinterest is an enormous site, so that's a swathe of traffic. So Google has actually built in web performance into their indexing. You might be already aware of this, but what you might not be aware of is the fact that it's only on the desktop side of things. So they're not actually ranking it on mobile. They have things like the AMP side of things, where they're going to show the little carousel and everything. But in the actual organic rankings, they're not yet taking it into mobile searches. Now, what they did announce back in January is that in July, so in a couple of months from now, they're actually going to make that the case. And if you think about how Google operates, they try and give the best results possible. They want to answer your questions in the fastest way possible so you can continue Googling for other things. So we know that mobile devices are a lot more restrictive than desktops. Desktop usually you're going to have a bit more power, you're going to have more memory, more CPU. You're hopefully going to be on a landline connection, so you've got broadband or fiber. Whereas mobiles, it's a lot more varied. You've got limited CPU, limited memory. At best, you've got 4G, which still has quite a lot of latency. In worst case scenarios, you've got even 2G or even like dial-up style connections. So hopefully, Google will be putting a heavier impact on performance when it comes to those rankings. So hopefully, we should start to see a real shift in terms of rankings and a focus on performance for mobile as well. Next one is conversion. So for anyone who was in Harry's talk yesterday, you might have seen this enormous quote, so I apologize for it. But effectively, for 100 milliseconds being chopped off your site, Mobify saw that their customers actually increased their conversion by over 1%, and that came out at over $375,000 extra a year in revenue. If we go down a more e-commerce slant on this, if you look at just decreasing that in the checkout rather than just on the homepage, you actually see an even greater benefit, seeing over 1.5% increase in conversion, and that led to over $500,000 extra a year across their client base. So this is pretty significant. And then the final part of the puzzle is the average order value. So this is an anecdote that I can give an example from. So we did a performance-led rebuild of a site from one of our clients. As part of that rebuild, we found that afterwards, The amount of pages people were viewing as they were browsing around the site increased by almost 10%. So people are consuming a lot more content. This correlated quite heavily with their average order value increasing as well. People are getting more immersed in the brands, and they're seeing more of the product range. Whether you offer subscriptions or physical items or digital downloads, whatever it may be, people are going to be more likely to come across products that they want to buy from you. So ultimately, you pair all this stuff together. It's not just one thing we're increasing with performance, it's all three. So you get this multiplying effect. But unfortunately, when it comes to actually doing this work, we all know it's not that easy, right? We've got to deal with clients. We've got to deal with stakeholders in our business. So I've got a few quick questions for you guys. How many of you think performance is important to the user experience? Can I get a quick show of hands? Yeah, hopefully, you might be in the wrong place otherwise, so that's good. How many of you actively want to build faster websites? It's quite an interesting thing. Great. And then finally, who feels that performance is undervalued by their clients or their stakeholders? Maybe it's just your manager. You're trying to get a little more time to do this work, but it's not as simple as that. Yeah, quite a few, right? So selling performance as a concept is quite tricky. So that's the basis of this talk today. This is one of my favorite quotes. It's easier to ask for forgiveness than it is to get permission. So if we can go and do some work that doesn't impact things like budgeting and extensive time, then that can be really valuable. Just on a side note, Grace Hopper, I don't know whether you guys have heard of her before. She's an absolute badass. She was a US naval officer. She wrote the first English-like programming language back in the 50s. And she only started computing at the age of 38. And she's done so much for computing, so kudos to her. So ultimately, out the back of this, you don't need performance. You don't need permission to build fast websites. So you might need permission to build the fastest site. If we're going to change things like content delivery networks, we're going to need to put in an image transformation CDN and pay thousands and thousands in terms of bandwidth. But there's plenty of tricks, low-hanging fruit that we can find in just the way that we structure our code that we can optimize and see great benefits from. So we're going to look at some of those today. But before we do start optimizing, there's a few things that we need to take care of first. So first of all, we need to be monitoring this stuff. You should be monitoring the performance of your site. You don't want to make things worse. You need to see the impact again against the actual user experience. It's really important that you're tracking things like the kind of business metrics, so your revenue, the traffic to your site, etc. Because the last thing that you want is something bad to happen to the business. Marketing just plummets. So there's a problem with Google, and it's nothing to do with your changes, and suddenly that gets linked to your performance changes. And similarly, if you see an uplift, you want to be the one that says, "Yep, I did that. We've done that." So you get that buy-in longer term. So if you're looking for kind of performance tools, you can look at like Calibre, Pingdom, you might have heard of, or SpeedCurve, and these are great tools for kind of monitoring this stuff long term. And then the second point is to actually understand your user base and build for the future. So when we start projects, a lot of the time we're dealing with quite large clients, so it'll be a long-term rebuild of a website. During that time, the browsers people use, the devices people use, they're all going to change. So if you're avoiding using certain techniques or certain CSS and other technologies that are coming into the web platform, the whole industry might have changed by the time your project actually goes live. So don't build for now, build for when you're actually going to go live, and then build for the future as well. If Internet Explorer 11 is a thing for you now, and then a couple of months after launch, it's not going to even show up on your analytics at all, is it worth building for that? Probably not. So once you have this, you can know what techniques you can actually apply. But a lot of what I'm going to show you today is stuff that will just simply fall back and be ignored by browsers that don't support it. So I couldn't run all of these tests against my live client sites. We optimized them all very, very heavily, but I didn't want to undo all of that work and throw all their revenue out of the way. So what I've done is I've built an open source project. You can find this on GitHub. It's called the slowest site in the world. It's a bit hyperbolic because it's not actually the slowest site in the world, but kind of averagely slow site that you can use for testing doesn't really kind of sound as good. Yeah, this is completely open source on GitHub. You can fork it and test applying changes to it. If you scroll down to the README, there's this Heroku Deploy button. So you can sign up for free on Heroku and literally just click that, enter a name for your app, and then it will deploy it for you. And then you've got an actual live site that you can then run these tests against. So what we're going to be using for testing today is web page test. This is webpagetest.org/easy. What this does is pre-fill the form, so it simplifies the form down. So this runs against a Moto G4, I think it is. So a kind of averagely powered Android device. And here it's saying slow 3G, but I actually used regular 3G for these tests. So it's just an option within that dropdown. And what it'll do is it'll make requests to the site. It'll kind of record all of the data about the waterfall and how resources are downloaded, and then gives us some stats on when did the user first see something. So the initial results of actually running the test against this unoptimized version of the site is pretty poor. If anyone's dealt with any of these metrics before, they're all really bad. So the top one, start render time, so no one sees anything. It's just a white screen for 6.4 seconds. Now, that doesn't sound like that long of a time, but it really is. After 3 seconds, you lose about 50% of your traffic. So this is a user just sat there looking, wondering, is this ever going to load for me? 50% of people are just going to go, you know what, I give up. So that's really, really bad. Our speed index, that measures how much of the site is visible over time. So the sooner you get content in front of somebody, the lower that value is going to be. We should be aiming for a couple of thousand max, and this is up at 12,000. The time to interactive is like, when can someone start scrolling around, pressing buttons, and actually interacting with your website? So again, this actually renders after. It becomes interactive before the first render. So it's actually limiting when the user can even use the site just purely by having to wait around for it to paint anything onto the device. And the final thing is bandwidth. We're using 2.5 megabytes of bandwidth for this site. That's an immense amount of data, particularly for users who are on capped data plans or just pay-as-you-go. We're costing people money by doing this to them. So it's just completely unfair. And this is all from a site that has only 16 requests. So 16 files have to be downloaded, and it takes 6.5 seconds to even see anything. So these are a lot of stats and a lot of diagrams. I can actually show you what it feels like in real life. So what web page test will do is it will provide you with a video version of the site loading. So you can actually see and feel the way that this works. And this is great for showing to stakeholders and showing them the kind of impacts that you're having. So I'm going to start this off. And remember, this is just average 3G, so not mega, mega slow. It's on an average Android device, so again, not mega, mega slow. So let's see what it looks like. So it's actually quite a long time. And now we get something. And then we've got this enormous image that gets downloaded. I'm kind of showing off my hometown there. This is a photograph of Leeds. And then at 18.2 seconds, the site's finally actually loaded in. So that's really, really bad. It's not a great experience at all. So what can we do to this? I'm going to break my own rule immediately. We're supposed to be looking at things that don't require infrastructure changes. But the first thing to just check is that you're going to have the right kind of connection. You might have infrastructure sat around that can have features enabled on it that you're not even aware of yet. So it's worthwhile getting to know your operations team or anyone in DevOps and seeing what kind of technologies are actually powering the sites that you're delivering. So the things to check for are gzip compression or Brotli. If you can just enable these, it should just be a toggle. Gzip should hopefully be enabled on every single site, but it's worth checking these things. OCSP is just the checking of a status of an SSL certificate. If you don't send that from the server, then your browser actually has to go away and check that that SSL certificate is valid manually from a completely different service. So you've got a single point of failure in there, and you put in that additional round trip before you can even make a connection to the site. So just check that that's enabled. HTTP2 is amazing if you've got it. It'll save you 30% of your load time on average. So if it's there and you can enable it, great, just turn it on. And then the final one is connection Keepalive. This should be enabled on every single site. But if you've got connection close, it will literally, after every single file, have to recreate a new connection. So that's a pretty silly thing to happen, but I have seen it. So if you can avoid that, then that's great. So just check whether these things are available. I'm not saying you have to replace your entire infrastructure, but if it's sat there, we might as well use it. So in terms of our actual code, we're going to start really, really small. We're actually just going to look purely at the head tag. So something absolutely tiny, but you'll see that even this can have a significant impact on our performance. So first thing to get right, and this is sourced from Harry Roberts. He hasn't actually posted this yet, so this is like a preview. Sorry, Harry. So if you get these things in the correct order, then you're going to see vastly improved performance. Start with your meta tags, so you need your character set in there, so your browser doesn't have to reparse the document. Get the viewport in there soon, and then the title tag, and that's really important. You want to get that in before any kind of synchronous scripts, otherwise people are just going to think that there's nothing there. If they can at least see the fact that the title's loaded into the top of the browser, then they know that something's coming along. Resource hints is something I'm going to cover on the next slide, so that's actually something we'll add in if you don't already have them. Any inline scripts, so you're literally just a script block in the actual HTML. Any external style sheets, so this could be either a third party or your own separate style sheet. Then you put your inline styles in, external scripts, and then finally just anything else. So you've got open graph tags, Twitter card, and all the other kind of bump that gets loaded into a site these days. So in terms of resource hints, there's kind of 4 main ones. There is a 5th one, which is not on here, which is pre-render, but I think it's being deprecated. So DNS Prefetch, you can tell a browser up front, hey, I'm going to need this domain, so can you at least look up the IP address for it? It's not a fairly common thing that I see. Pre-connect is probably more common. So if you know the protocol that you're going to be connecting over, i.e. HTTP or HTTPS, you can say, not only do the DNS lookup, but actually warm up a connection for me. So rather than waiting until you need a file from a certain server, you can just say to the browser, hey, go ahead and make this connection. When it's ready, I'll download that file. Prefetch and Preload are somewhat similar, but effectively the main difference here is that Prefetch will actually download resources and actually parse them, and Preload will just get them ready in your cache. So the two that I'm really focused on here are Preconnect and Preload. So if you see something like this, I've highlighted a font here. You can see that we're actually creating a connection to this far after we've started loading any CSS and any HTML. So what we're doing is the browser's just waiting until it actually needs that file to make that connection. Now that's just wasted time. We want to get those fonts in sooner. So effectively, we can tell the browser, hey, connect to this beforehand. We know that we're going to be needing these fonts. So we don't know what the file name may change. So we'll just connect to the domain. But we know that we're going to need that connection. So these resource hints have pretty great support. Again, they're completely progressive enhancement. So effectively, if your browser doesn't support them, you will see no difference other than the fact that things might be a little bit slower. So there's no reason not to use these. Preload is the same. Wow, that's really bright. And this one allows us to tell a browser specifically to download a file. So if you know the URL and it's going to be permanently the same URL, you can tell it up front, hey, download this file, we're going to need it in a bit. So what are the results against our test site? Once we've applied just these things that don't change the user experience whatsoever, it's completely invisible to a user, what actually is the result out the back of it? We've chopped down 1.8 seconds off that start render time. So where we were waiting 6.5 seconds, it's now 4.5. Speed index bizarrely has gone up slightly. Not really sure why that happened, but it's such a minor thing compared to that 12,000 that it could just be a statistical anomaly. We've not really changed our JavaScript at all, so in terms of the time to interactive, that's not really changed. It's been brought forward just slightly because we've improved the network situation. But ultimately, if you look at the value, if we go back to those Mobify quotes, you can see that this is worth over $6 million a year. If you've got a reasonable site, this is a lot of money. So we haven't even changed anything about the user experience. We haven't changed our images, our CSS, our JavaScript. We've just made some very, very minor tweaks to the head of our HTML. So the next one we're going to move on to is images. This is something that a lot of people have known about for a while. You know, you're not supposed to be sending these enormous images down, but we'll actually see that this not only improves our overall page loading time in terms of that speed index getting more content in front of a user sooner, but actually because we're offloading a bit from the network and reducing that pressure a little bit, we actually get earlier start render times as well. So I'm sure you're all aware that you can load images in the foreground and images in the background. You've got image tags in your HTML, and you've got background image in your CSS. So there's two ways of loading images. But what you may not be aware of is that the browsers will treat these completely differently. Browsers see foreground images, the ones in your HTML. It will see those as high priority, so it will get them in there sooner. It's content that you're trying to show to a user. But background images, it goes, well, it's kind of sat in the background. We don't necessarily need these. Hopefully, you've got a background color, so whilst this image is loading, it's got a nice box around it. It's not just invisible. So it deprioritizes those images. So if you look at our waterfall chart, you'll see that we're loading in loads of product images, which are actually beneath the fold on this particular site. And then we're loading the hero image, which is the big one in the middle, which is completely the wrong way around because the hero is set to a background image using CSS. So if we correct that, we'll see that our hero has jumped right up to the top. Product images are now further down. And what you may have noticed, it's kind of unclear, but you see the logos loading in the middle of there. What I've actually done as part of this is inline that in as well. So within that image tag, we now have the data for that logo as well. So that's actually disappeared. That logo gets there in front of the user as soon as humanly possible, as soon as they got the HTML. It's right there waiting to be rendered. So your branding and the confirmation that the user is in the correct place immediately shows up for the visitor. So I mentioned the images that were beneath the fold, these products that we have on the site. What we should be doing really is lazy loading them. We don't need them as part of the initial render. Browsers will progressively load these images anyway, but if you've got an enormous site, why are you loading all of that data when someone's probably not going to scroll all the way to the bottom? So what we should really be doing is looking at these images and saying, OK, well, how about we load them as we start to scroll? Maybe we might want to load these two up front, because they're quite near to the bottom of the viewport. But if you've got a whole raft of these going down, then we don't want them all to come in. So there's kind of three principles that we need to deal with when we're using lazy loading. First of all, we need to set the actual image size of these images before we're loading them in. The last thing you want is to reflow the page. As you're scrolling down and like ads are coming in and things like that, you don't want the text to be jumping up and down. You don't want to have that repainting happening. So effectively, if you set those dimensions even when it's not loaded, so just on the preview on the right, then the browser's not having to do that reflowing. Second point is to build in that threshold. So have a reasonable amount of time, at a reasonable distance beneath the actual viewport where you're loading those images in. We don't want to really be showing users these preview images at all. So we want to make sure that as they're scrolling in a normal way, those images are already going to be there, and it feels like they were always there. But obviously, you're going to get the case where someone's going down to your footer, and they're going to flick straight past them. So that will cause a bit of difference there. But we can embed a preview image. So effectively, we're not going to just show like a blank space. They're not going to be like, oh, half the site hasn't loaded. And there is something there. And there is a follow-up technique that you can enhance on this site. You can actually use the medium.com technique. I don't think they were the people to invent this, but they certainly popularized it. So they show a blurred version, a really low-res copy of an image. And then as the full-res version is loaded, they actually replace that in. So it's quite a nice thing. It feels pretty good. It's better than just a square with a little icon in it. But as far as I'm aware, there's no actual proof that this feels better to users. It feels better to me, at least. But if you have the capability of producing this blurred image as a preview, then it's certainly worthwhile exploring. So the next point with our images is that we need to serve the appropriate sizes. We don't want to be serving desktop images, particularly nowadays when mobile is getting bigger and bigger and bigger. I have clients where 70–80% of their traffic is mobile and tablet. So we shouldn't really be focusing on desktop at all anymore. That should be like the afterthought. We should really be focusing on how do we get our content in front of people on mobile and tablet devices first. This will obviously depend on your traffic patterns, but effectively, serving an enormous image down to a mobile doesn't really make sense. It's actually better, probably, to serve a low-res image up to a desktop and have it be a bit blurry. Obviously, there's going to be more of an impact there, so you might not be able to get it in front of a client. You might actually need permission for that. But if you have the capability of rendering out multiple different sizes, if you've got some sort of thumbnailing library, then you should be producing multiple sizes of an image for each device. So the way that we do this is we use SourceSet. It's got great support across all of the major browsers. IE11 is pretty much the only one that doesn't have it. And effectively, that will just fall back to using the source attribute. And I'll show kind of an example of how that works in a short while. So there's no real reason why we shouldn't be using this. It's a fairly basic format. It's just an attribute. And it allows us to show different image sizes at different dimensions. We don't just want to serve the right dimensions, though. We need to also serve the correct formats. This one's a bit more tricky because we actually have about 4 or 5 different kind of photographic formats on the web now. So one you may have heard of is WebP. This is from Google. This is far more optimized than a JPEG, but it's only supported by Chrome. So effectively, you're very limited in terms of the amount of users who will access this. Then we have JPEG 2000. This one's only in Safari. And then we have JPEG XR, which is only in Internet Explorer and Edge. So we need to serve these different formats to different devices, depending on what they support. Now, the easiest way to do this is to employ some service like Imagix or Cloudinary that will do all that transformation for you. But that costs money. You've got to implement it. You've got to set up contracts and sign service agreements and all this kind of stuff. So what can we do on our own? There is a way to do this just purely with HTML. So obviously, you'll need to output these formats. So it will depend on your tooling. There's this tool that you can do anything manual. So if you're running any static sites at all, or any where content doesn't change that often, you can throw your source image into this tool, and it will spit out all the different versions for you. I will apologize. It's one of those kind of cross-platform Java apps, so it's not the best-looking thing in the world, but it does work. And what we can do is we can combine these into a picture element. Again, pretty great support. And there is a great polyfill for this, just called picture fill. And that will support all the way back to, I think, IE9. So 11 and below can use that. And it's a really simple format. This is all the code we need. So this includes the source set as well. So we've got an outer picture tag. And within that, we've got 3 different sources. These are our different formats. So you can see each one has a type attribute. We just tell the browser, this is the MIME type for JPEG XR, JPEG 2000, WebP, and it will pick the one that it can use and serve those images. I've wrapped in these IE9 tags. This is just a little kind of hack to make it work for IE9. So if you don't need IE9 support, you can just remove those. And then at the bottom, you'll see that we've got our image tag. So this is just a fallback. So if none of those are supported, we just fall back to regular JPEG. And then within here, we've got a similar fallback for our source set. So we're defining different URLs and then telling it for different widths of the image. So we're saying if the image is going to be 1600 pixels wide, use the 1600 pixel JPEG, etc. And it will pick the most appropriate format for each. Again, fall back to just the regular source tag. So for browsers that don't support source set, you've still got support there. The image is still going to show just as normal. So what are the results from this? Again, $6 million a year in revenue, pretty significant. We've chopped almost 2 seconds off our start render time. Our speed index is far lower now. We've got rid of all those big chunky images that just slowly load in. Our interactive time hasn't really changed because, again, we've not really touched JavaScript. And our bandwidth's just gone through the floor. We've got about 370 kilobytes now instead of 2.5 megabytes. So that's quite significant. We're now treating our users with a bit more respect when it comes to their data plans. Now, I could rattle on about images for a while, but there is an excellent guide. So if you need any more information on this stuff, just go to images.guide, and that has a full multi-page document about how to serve images in the best way. So we're going to go into another simple approach. Look at our CSS. I've just got a few little things that you can do here that will improve performance. So we've got removing imports Any import to a third party or even imports to your first party are going to have this kind of knock-on effect of one resource having to load after another, having to load after another. So it's not a parallel loading process. What we can do is use resource hints to get around that, but ultimately we can just do this by removing it altogether and having one style sheet or one inline style that solves all of this for us. If you're using a third party with import, this means that you've got a single point of failure on your site. If their CSS doesn't load or it's just slow, you're putting all that time onto the user. So it's particularly bad if you're referencing external style sheets, things like Google fonts and things like that. So if you can, inline your CSS. This is one thing that I praise AMP for, is that they force you to inline all your CSS. They actually limit it to 50 kilobytes as well, so they're kind of making sure that the browser only needs a few round trips to get all that data. But if you can, inline the CSS that you have above the folds. You can use various different build tools for this. I think there's a library on NPM just called Critical that pretty much works with anything. And then anything that's beneath the fold, so like I've got those styles for those images, that can just come in asynchronously after the site is actually loaded. So you're getting that content in front of someone immediately. As soon as they start to scroll, they're going to see that the CSS is loaded beneath anyway. So it should be an invisible impact to anyone. So what are the results of this? Well, this one didn't actually make that much difference. We didn't have an enormous CSS payload. We didn't have loads of third parties. It's loading in some web fonts from Google, but that's about it. So the impact, whilst we still shaved off 100 milliseconds, so this revenue from Mobify is still pretty significant if you're running a big site, but we haven't made that much of a difference. But this is whilst our third parties are operating fine. Imagine Google has an outage. This would be the difference. We'd have start render time go absolutely through the roof. Harry mentioned yesterday that you're waiting around for 90 seconds before Chrome will give up on a file. So if Google's doing that to you, you can see that we've actually improved by applying these techniques and removing that third party. We've improved things by 90 seconds there. Speed index, it couldn't even calculate it, so it's effectively minus infinity. And the other ones haven't really changed. So the value of this, obviously this is not going to be correct for anyone. Google Fonts is not going to be offline effectively for an entire year, but over 300 million. But if you think about it as just being offline for just an hour, this is still costing us $40,000. So that's a little more of a realistic case. And any additional load time that they're adding, if they just go slow for a little bit, this is a complete outage. If they're going slow for a bit, that could be happening all the time. Unless you're monitoring all of these third parties and you're very, very aware of it, this could all be happening in the background. So the next one we're going to move on to is JavaScript. So this one's a much more tricky one to optimize because everyone's got a completely different stack. So I'm just going to focus on this initial kind of time to interactive and the actual network. So we're going to talk about some kind of higher level stuff. So the first thing to look at is how we're actually loading in our JavaScript files. We should all know by now that relying on synchronous scripts is going to be a serious problem for us. Those are going to download and block everything else from occurring. So ideally, at the bare minimum, we should be using async. So what this allows us to do is download the file, and then the browser will just simply execute it whenever it's been received. But one thing to be mindful of is that there's this other tag called defer, this attribute called defer, that you can also apply to your JavaScript script tags. And what this one will do is actually wait until the entire page is loaded before it executes. So if you've got a heavy bit of JavaScript hitting the CPU, you can actually push that out until everything else is loaded and give the browser a cleaner approach to actually loading in the initial view of the site. So if you've got things like analytics scripts and things like that, they're just collecting some data and then sending it off to a third party. You don't need that to happen as part of your actual loading of your site. That can happen a second or two later. So it's good to be mindful of these different approaches and use the most appropriate for your site. If you see anything like this, where you're loading in libraries from third parties, again, a lot of the time these will be synchronous because you're like, I need to depend on jQuery being there, so I'll load it in as a synchronous tag. That's a bad thing. But if if you're referencing a specific version of jQuery or any other library, which you hopefully should be, then you might as well just build that into your actual JavaScript itself. So just copy down the file, put it within your existing script, and then you're not having to make that connection to the third party. You're not having to negotiate SSL and all that kind of thing. And you're not dependent on them being up for your site to even work. So just clone down that file and build it as part of your script. We all know that JavaScript isn't just about the download, though. There's a lot that goes on in the CPU. There's a lot more focus on this. We're throwing a lot more functionality into sites these days. So there's far more that we have to do. Once we've downloaded it, we have to parse it, we have to compile it and execute it. So the browser's got a lot to do. On limited mobile devices with slow CPUs, you can grind things to a halt or even crash the browser. So again, this will all depend on what kind of application you're building. If you're building something in React or Angular or anything else, you'll have to optimize those in very different ways. But as general principles, if you have smaller JavaScript, you're probably going to have less hitting the CPU. There's less to compile. So effectively, there's two things we should be doing here. Number one is bundling our JavaScript together. We need to get the correct bundles. So ideally, you don't want to be serving more than the user needs for that page. But at the same time, you're going to get better compression the more you bundle together. And then tree shaking, where you just remove any libraries that you're not actually dependent upon. So the results of this, we've not really changed our start render times or our speed index. Bandwidth was minor decrement because we've got better compression about bundling those files together. But the main one is this time to interactive. So now we've chopped off over 2 seconds sooner. People can start actually interacting with the site. So this is pretty impressive. And then the final section I've got for you is web fonts. This is something that's tremendously undervalued in terms of its impact on performance. A lot of providers will tell you, hey, here's a style sheet, just go and put it on your site, and it'll load in a pretty unoptimal way. So if at all possible, self-host your fonts. Just like JavaScript libraries, just like your CSS, you shouldn't be putting delivery in the hands of a third party. So if at all possible, literally just bundle it in with everything else. You avoid a DNS lookup, you avoid another connection, you avoid an SSL handshake. Now, the only thing to bear in mind here is that if you are using Google Fonts, they will detect things like Windows and hint the font slightly, so they may render slightly different on Windows. So it'll depend how advanced you want to get with that. But as a general principle, if you can host them yourself, do. Again, like images, we should be serving the correct format. Basically, the correct format for fonts is WAF2. That's the latest compression. So the only time that we'd ever have to serve another format really is for IE 11 and back to IE 9, where you need WAF 1. But with that, effectively, you might just want to fall back to a native font and just not serve custom fonts for those ones. Now, we can actually start to control the network in terms of how we download these fonts now as well. There's a new attribute in CSS called font display, and this allows us to say, hey, browser, I want you to download this font and render in a particular way. So effectively, my favorite one is swap. What this does is say, hey, render with the fallback fonts for now, so just using something like Helvetica or sans serif or whatever it may be. Whatever your stack is, it will just fall back to the next one. And then go away and load this font file. Once it's loaded, swap in the correct version. So we'll get a repaint there, but hopefully your fallback font will be similar enough to your main font that effectively it won't be too jarring to the user. Now, if it is going to be quite jarring, what you may want to use is optional. So what this says is, if we load that font file in and it loads pretty quickly, like within maybe a couple of seconds, yeah, we'll just render with that nice font file. But if it takes any longer than that, don't paint it for this page. Just keep it in your cache. We'll use it in the future, but we won't use it right now. So what this allows us to say is we're going to control the user experience a little bit more. We're not going to show that kind of switching over, and then we can use it in future. Now, the only thing to be mindful of here is if you've got a single-page application, you're not going to have that second view unless people literally leave the site and come back in future. So that's not ideal for that situation. You may want to use swap in that regard. So this doesn't have the best support in the world. It's one of those things that has that progressive enhancement. So you can effectively just fall back and it will just block. But it can be a significant improvement for the browsers that do support it. The only other improvement that we've got here is Unicode Range. This allows you to say, break up your font into multiple files and only load the files for the text that you need on the page. So if you've got a lot of like Arabic text and things with accents, then you can effectively break those off into separate font files. And this is something that Google Fonts does. So if you look at a Google font file, in terms of the CSS, you'll see it looks something like this. I've changed the URLs to be local hosted now. So we're actually self-hosting those. The Unicode range is just saying, OK, these different glyphs, these different letters and characters, these are what are in this font file. And the final one we've just added at the bottom is this font display swap. So the results of this one, start render, similar to our first improvements. We've chopped off 1.8 seconds. But because it's a font, there's a very minor change there. So our speed index has improved, but only slightly. It's not a major change to the actual view. And again, 6 million a year in terms of the revenue. So another benefit here is that we've removed that single point of failure. So like with our CSS, if Google Fonts was going slow, we're now not impacted by that. So what happens when we apply all of these things together? What's the actual result of all of this stuff? Our start render time is actually dropped by 3.8 seconds. So we're getting this compound effect of these techniques working together. Our speed index is about a third of what it used to be. Our time to interactive is a half, and our bandwidth is way down at that 370 kilobytes or so. So the value of this in terms of Mobify's clients would be 14 million a year in terms of their revenue. So it's quite significant. And what I'm going to show you now is the comparison videos, so we can actually see how they feel in real life in terms of them actually loading. So I'll keep an eye on the right one because that one's going to load a lot faster, and then you'll see how it compares to the original on the left. So within a couple of seconds, we get our text loading in. We see the font adjusted slightly, and then the image loaded in, whereas this all happened and it completed loading before the original had even started showing anything to the user at all. So you can see the level of improvement there. So if there's anything to take away from this talk, it's just the fact that there's a lot of low-hanging fruit for most sites out there. Most sites might only have a few of these optimizations that are missing, but you can still improve things to a vast extent. We looked at things like just reordering those head tags. Simple stuff, but had an enormous impact. So I've got time, I think, for a quick bonus point. This is more of a protection mechanism. So you may have heard of service workers. They're one of the requirements for progressive web apps, allow you to do things like offline support. They're pretty well supported. A couple of weeks ago, the latest version of Edge came out, and they're now in that. So all the major browsers, all the latest versions of the major browsers are now supporting them. It's a progressive enhancement, so it's one of those things where it'll fall back and be invisible to anyone who doesn't support it. But you get a whole host of things here. You get the ability to control the network. You can actually interrupt requests going out and responses coming back and actually modify them if you wanted to. You can provide offline support, so that's how you say, OK, we're offline. I'm just going to give you back this HTML or these files, so you can actually see something whilst you're offline. You get support for progressive web apps, as I mentioned, and then you can actually do these more advanced things. So you can do stale while revalidate, which is effectively where you say, OK, you've been to this site before, you've seen this page before, I'll give you that version in the background, I'm going to go away and refresh that, so the next time you come back, it's the latest version. So people get the fastest possible response there, but they're also keeping their cache somewhat up to date in the background. Similarly to this, you can use stale while error. So this basically says, if I get a timeout on requesting a particular file, or if I actually get an error back from a server, I can just show the old version of the content from the cache. And then the final one, which I'm going to show you here, is you can protect against the slowdown or even outages of third parties using this. So it's just a few lines of code. All this basically says is when we fetch a file, when we make a request out, and you may want to limit this to certain domains or certain third parties, when we make this request, time it out after 2 seconds and force that. So rather than waiting for those 90 seconds that Chrome gives you, just wait 2. And if we don't get it back in that time, what we're going to do is actually serve a synthetic response, a fake response, that just says, yeah, this file timed out. So this is particularly useful for things like A/B testing tools. Traditionally, they're loaded in synchronously, and that means that you've got this single point of failure on every single page of your site. And if there's any latency there, if people are on really slow devices, well, do you need those customizations? Probably not. Just giving them something is going to be better than giving them all your tests and achieving that extra data. So this is just a quick way to, you literally just drop this in a file pretty much. This is a quick way to protect against that. So this talk was based on an article that I wrote for Heart Internet. It's part of a much larger book called Build Faster Websites. It's a free ebook. The URL's at the bottom. I'll ping out the slides on Twitter after this, so you don't have to write this down. But there's a whole raft of different content in here. I really recommend downloading this PDF. It's just online. And thank you, everyone.